Hello viewers, you are welcome to my class. Into this tutorial today we are going to be looking at this question on this board. So now the question says solve 4 to power 1 over x minus 6 to power 1 over x equals to 9 to power 1 over x. So now what are we going to do? So the first thing we are going to do here is to divide through by what? 9 to power 1 over x, and this is what we are going to have. So we have this when we divide through by 9 to power x, and this implies that for the fact that these two 4 and 9 they are having the same powers. Okay, so we can write it as 4 over 9, okay, then 1 over x, then minus the same thing here. I have 6 over 9, then 1 over x, and this becomes 1 here. Are you getting it now? So now from here, so the next thing we are going to do is we can actually write this as in index form, that is 2 over what? This 9 can also be 3 and put the square here, that is 2 square give us 4, 3 squared give me 9. So therefore I have what? I have the power outside, that is 1 over x, like this. Then also here I can try to divide this one, dividing 6 by 3, I'm going to have what? I'm going to have 2. Then dividing 9 by 3, I'm going to have what? I'm going to divide 3. Then we have what? 1 over what? To power 1 over x, then equals to what? Equals to 1. So now from here, so the next thing we are going to do is we can see that I can actually rearrange this by what? By bringing this power inside and take what? And take these two outside. That is, when you have a to power b, then we have c outside. So this can be a, put c inside, and what? And have your b outside. Are you getting it now? So now that is from the law of indices. So the same thing we want to do here. So I can have 2 over 3, okay, 1 to power 1 over x. Then I put what? I put 2 outside, like this, minus what? Minus 2 over 3, then to power 1 over x equals to what? Equals to 1. So now from here, so we can let this, you can say what we have here is same thing with what we have here. So we can say let a to be equals to 2 over 3, okay, then to power 1 over x. Are you getting it now? So now from there, so the next thing we are going to do is anywhere we see what we see 2 over 3 to power 1 over x, we replace it in this what? In this equation. So we are going to be having a squared minus a, then we have this 1 here. This 1 can actually come to the left hand side to become minus 1, then we have 0. So now from here, so the next thing we are going to do, so we are going to see that this is what? This is an equation in terms of what? In terms of a, that is quadratic equation in terms of a. So this can be, now doing this, we cannot actually use what? We cannot actually use our factorization method here, but we are going to what? We are going to see that use quadratic formula. So now we have our a to be 1, okay, we have our b to be what? Minus 1, we have c to be what? Minus 1. Using this formula, as squared plus what? Plus bx plus c equals to 0. Are you getting now? So therefore, comparing this with this, we can say our a is 1, we have b to be minus 1, and c to be that. So therefore, we are going to be having the value of a. Now from here, we see that our a is going to be, so we have a to be equals to 1 plus all of this. We have what? We have minus 1 squared give us what? Give us 1 plus what? Minus 4 times this, we are going to be having what? We are going to be having plus 4, then divided by what? Divided by 2 here. So we have the two values of what? The two values of a to be a equals to what? 1 plus root what? Root 5 over 2, or 1 minus root 5 over 2. So don't forget that we are not looking for the value of a. So now the value we are looking for is what? Is x. So therefore we are going to recall that a is what? Is equals to 2 over 3, okay, then to power 1 over x. Do you understand now? So from there, so the next thing we are going to do, we are going to see that we can replace this to be what? 1 plus root 5 over 2. So the reason why I considered what? I considered this positive is because this turns to what, to base here. I get it now. So therefore this left hand side cannot be what, to cannot be give us negative value. Okay, so therefore we are going to consider this and consider this one invalid. Do you understand now? So because is what is negative. So now from here, what we are going to do now is that we are going to what, we are going to introduce what, introduce a natural log. Or before that, so this one here is called what, is called a golden ratio, and it is represented or denoted to be what, to be phi. So therefore we are going to be having a equals to 2 over 3, okay, to power 1 over x, so equals to what, equals to pi. So that from there we try to introduce natural log to the both sides. So we are going to be having ln, okay, 2 over 3 1 over x equals to ln what, ln phi. So now from here we have what, we have this 1 over x will come to the back here. We have ln, then 2 over what, 2 over 3 equals to what, ln what, ln phi. So now from here, so the next thing we are going to do is that we are going to divide through by what, this. We have ln 2 over 3, okay, then ln 2 over 3. Is that understood? So that from here we can see that this can actually be written as ln phi, okay, over ln 2 minus what, ln 3. So we have 1 over x to be equals to ln phi over ln 2 minus ln 3, and we cannot leave it this way. So this is going to be now taking the reciprocal of these two sides. I guess now, so we are going to have x over 1 equals to, you know, the power, the numerators and the what, and the denominator will have to be interchanged. You have ln 2 minus ln 3 over ln what, ln phi. So don't forget that this is what, this is the solution to the problem, that is x equals to ln 2 minus ln 3 over ln phi, and this phi is what is called, what is called golden what, golden ratio. Thank you for watching. Bye.